to have an insight into the Earth. We are going to imagine a plane or a blade is cutting through the Earth. What can we see about, or what makes up the internal composition of the Earth? We can see the white region, the yellow region, as well as the orange region. What do they signify? The Earth and the other planets, how are they formed? How are we going to use the Big Bang Theory to explain this formation? Having formed the planet Earth, or for planet Earth to be formed, what are those things that can make it to become a planet? These and more are what we are going to be learning as far as this course is concerned. So let's start with the universe we inhabit today is the result of a long and a very long evolutionary process. And that process starts from what is called the Big Bang Theory. So, how the universe is formed, as well as the solar system, we can attribute their formation to the Big Bang Theory. So, we are looking at the Big Bang Theory and the formation of solar system. Please, once again, I've asked you to mute yourself. Otherwise, I will sign you out of the class. Abdulateef Adejare, please mute yourself. Ademuyiwa, mute yourself. Otherwise, I will sign you out of the class. We are looking at how the universe and the solar system, how they are formed using the evolutionary process, as well as the tectonic activities that result from the Big Bang Theory. So the Big Bang Theory stands as the cornerstone of modern cosmology. It offers a profound understanding of how the universe itself came into existence. It reveals, or it tells us, as regards the cosmic expansion, the birth of the galaxy, and eventually the emergence of our very own solar system. So we see how the Big Bang Theory has widened our understanding of the universe, the cosmic expansion that takes place, how the galaxies are formed, and eventually the emergence of the solar system, of which the Earth that you and I we are in is made of. The Big Bang theory was proposed in the early 20th century. We can say the universe originates from an infinitely dense and hot point known as a singularity. Again, we can posit, or we can say that the universe is formed from an infinitely dense and hot point. That dense and hot point is actually known as singularity. And if we are going to date that back to the geological time scale, it is approximately about 13.8 billion years ago. It is approximately about 13.8 billion years ago. So that singularity suddenly expanded. The singularity suddenly, where that is the infinitely dense and hot spot, which we call singularity, that I've shown you in the slide. That is what you can see in the slide. So it expands and it gives rise to space, time, and matter. So as the singularity expands, if it gives, the expansion gave rise to space, as well as time, as well as matter. So as the universe expands, it cools and matter began to form, eventually coming together into galaxy. From galaxies, we have the star as well as the planets. Another thing we need to take into cognizance as far as the formation of the universe, after the expansion, or after expansion has taken place, we have the galaxies and the stars and the planets. We can also relate them to be as a result of massive cloud of gas and dust. So when cloud of gas and dust come together, they form what is called the solar nebula. And that is what you can see from what I have projected, or what is being projected. You see hot gas and dust coming together, forming stars. So stars are formed from the fusion